Oops. Were there any questions so far from this? Some people are still at 6. Some people have finished this whole section and are on to the next unit. Now, for those who did finish and even those who haven't got up to it, could you tell me what was the trick or what did you learn with the fractions with question 11? So if you were to tell someone, oh yeah, this is what you have to do when you've got fractions, fractionies, what was there's a little bit of a pattern I think you should have come up with. Anyone? Wait, I'm traveling, the traveling mic, mystery student. You can see who this is.
So like with 11b, it's 7 on 4 to the -1. When you got to the -1, you literally just flip the fraction.
Correct. You flip it, right? So when it's negative, you flippy dippy. We should know that anything to the power of 0, that's just 1, so that's not in the game. With this one, we just flip, right? Why? Because you would go everything in the bracket gets that power because there's just dividesies there. And then you go, oh, when it's a negative downstairs, to get rid of the negative power, you chuck it upstairs. If there's a negative power upstairs, you chuck it downstairs. And so before you do a heap of these, you just realise, as Brody has, I'll just flip it, man. Just flip it. So if I then have 2/3 to the -2, what would that be? So one at a time, yeah. So first, to get rid of the negative, just flip it. So that would be the same as 3/2 squared, agreed? And then the rule that we have, everything in the bracket, it's going to get that power. Oops. So that's going to be 9 all over 4. Right, so pretty good, pretty good. So if you haven't done them, you will do them quite quickly. What about when you have something like G? G or GG or? You have to change it to? An yeah, that's mixed, improper. Good. So when we've got, what was it? 1 and 2/3. I can't even remember. What was it? -2, -3. You're as bad as me. Okay, good. I don't feel so bad. Oh, you got it. Okay, you're better than me. So we change that. 1 times 3 is 3, plus 2 is 5. I'd really appreciate it if you're not talking. To the -3, and then like we did before, we just flippy dippy. Now, it's last lesson on a Friday. Ooh, you might not be in the zone. Just recall, I mean, I think I can count on my hands the number of times I've used it, but how do we enter a mixed fraction into our calculator? Shift, ka-ching. Okay, so I could go 2, 8, 17. Huzzah. And then if I press this one here, right, shift, I think it's that one. No, wrong. Shift, it changes it back. Changes it back. So know what your calculator can do. I'd like to think you never need it because it's fractions. Come on, kids. All right. Oops. Oops. Okay, so just working your way through. So you need to get a wiggle on and you need to finish that, I would say, over the weekend because I'm moving along, little doggy. Scientific notation, yeah, we'll pop that in later, but that's quite simple. You have a look. People were asking about, ooh, what is with this rational? It's the same thing. Okay, you've got a rule, we follow it. We talked about this last lesson when we said the square root of something is anything to the half. The cube root is to the 1/3. If it was the 4th root, it would be to the 1/4, etc., etc. Coops is yawning, and if he has gum, he's going to put it in the bin. So when we've got this, are you chewing gum? Are you? That would be a yes. No gum in my room unless you want to be cleaning the desks. And that's not the top of the desks, that's underneath. Scrapey, scrapey, scrapey. Okay, so. Right, so this would just be 2 to the 1/5. Correct? What did we learn from before? Ooh, this is technically 1 over 2 to the 1/5, but we don't want it downstairs. We want to move it upstairs. So what do? The power becomes negative. So really you're just adding one step. What about this? This is technically 2 to the 1, so I'm going to write this. 2 to the 1 times 2 to the half. So now, same base, what can I do to the powers? So Morgie Meister, you're not even up to this, but it's the same stuff, right? Same stuff. It's just with a fraction in there. It's nothing different. So you'd be able to zoom through this. So timesing by this, so pay attention to this because this is all you're doing. What do? We add them up. I am a fan of saying 1.5 is 3 over 2. If you write 1.5, that is fine. If you see the textbook saying 3 over 2, you know you've got the same answer. Try and do it as 3 over 2 because that helps with integration and differentiation. Now, we were doing some of these without the fractiony stuff. We want it as a power of 2. Can you remember what we have to do? Big Tom? Who can remember what we have to do? Right, the root 2, at least we can do that and we can say that is 2 to the half. But what about this 4? What's going on there? It's 2 squared. That's right. They're not going to give it to you as 5 or 11. It'll be something that you can write as 2 to the something, okay? Stop there. No. Negatory, the same base. Timesing by the same base. What do? Plus the powers, yep. So 2.5, or you can say it's 5 over 2, right? Again, if you want to write 2.5, go forth. Same thing. Capiche? So people who said, oh, fractions, you okay? So I'm going to give you like 10 minutes. I know that's not long, but 10 minutes to go your hardest. What we're then going to be doing is using these rules again to solve. So you get practice on them again, but you do need to make sure you finish. Go, you good thing. Quick look. This is just using your calculator. It's just going to your power button, okay? So going up, let's do, right, to the whatever fifth that is. I forgot what it couldn't see. 4 to the minus 3/5. You asked, you were not listening. So Tom, we're silent or we're putting our hand up to ask a question. So we go down here, it's 4 to the, right, 4 to the, and then minus 3 fraction over 5. It's that simple. Huzzah. Not very pleasant. Right, what about 8 to the 4th root? So it's 8. This thing here is your 4th root. So you can go, I should have done that first. So we're going to go, bloop. I can pop in the 4. Oops, I can pop in the 8. I go, I don't like that. How else could I have popped that into my calculator with a to the? 1 over 4, right? The 4th root is the same as a quarter. Same deal. Happy days? Coops, you all right with that? Okay, looking at this one without a calculator. Right in simplest rational form. Quite nice. So we have a look and deals with fractions. So 3 over 2, would you agree? I can split 3 over 2 is the same as a half times 3. Would you agree? A half times 3 is 3 over 2. Why is that helpful? Because this would then be, do you agree? Well, what's 4 to the half? Square root of 4 is 2. And you've got 2 cubed. So you're basically splitting this. So again, look at 5 over 3. Do we agree that 5 over 3 is 1/3 times 5? Why does that help? Well, this means I can say this is 8 to the 1/3 to the 5. Agreed? Why should we know what 8, the cube root of 8 is? right? Don't be offended. But the cube root of 8 is 2. And that's one of those things that we should now be familiar with. Like a quarter is 0.25. We should know 2 cubed is 8. So this now becomes 2 to the 5. I know I'm pushing my luck to go, what's 2 to the 5? But hey, use your fingers, that's right. 2 2s are 4, 4 2s are 8, double it 16, double that 32. No calculator in sight. Are we getting the gist of this? Lo and behold, 16. That's going to be to the what? How can I split 3/4? 1/4. What is the 4th root of 16? What a shock it's going to be. Not 4, because if you say 4, you're saying 4 times 4 times 4 times 4 equals 16, and that's not right. 2, that's right. It's always going to be small numbers, quite frankly, right? So, and do we know what 2 cubed is? 8. So you can check this on your calculator and see that you're right. But do we understand how we're splitting? I mean, by all means, you could have split the other way. You could have gone 16 cubed and then gone to the quarter. Why would that not be a sensible option? Can you work that out without a calculator? 16 times 16 times 16? I can't. Well, I could on a piece of paper, but yeah. So you don't want to do that, correct? So who would like to do D? How we're going to split the 3 on 2? Morgie Meist?
In the brackets 25.
Yep.
The power of 1/2.
Excellent. He's a legend. And then cubed. And we go, sweet. Half now. You know, we're just automatically going. It says square root. Absolutely. 5. 5 cubed. Have you come across that a lot? 5 5s are 25. 25 times 3. 125. Would they expect you to know what 5 to the 4 is? No. Would I expect you to know what 3 to the 4 is? Yes. It's a common one. Anyone? 81. Anyway, the more you do, the better you get. Make sense? Ooh, halt. Now, no, don't keep packing up. I wanted to go through some more stuff. I was going to put this down as extension, but I'm now going to ask you to actually do, when I was talking to some people, it wasn't as straightforward as they thought it was. But anyway, so could you also please do 2F1? Right, you're just expanding. And then, I mean, hello, wait. I've got 1 whole minute. So, I will make you unpack. What would this be? X squared times x cubed. X to the 5 plus 2x to the 4 plus, sorry, I keep having my back to you. Like, we do that without even thinking. And technically what you are doing, same base, you're adding the powers, correct? All they're going to ask you to do is, can you do it now if you've got a fraction and a negative out the front? But it's the same process. So can you please practice? Okay, so 2F1, you may pack up.